But Mr. J, what about number 4? We don't have all the info. All right, let's break it down. We have a student trying to lift a 0.0837 kilogram pith ball. Now, 0.0837 is a itty bitty little something or other. That's kilograms, which means that's its mass. We have the mass of that ball. Trying to lift it off the ground. So we want to determine all the unknowns. The instant the pith ball begins to lift off the ground as the electric force matches the gravitational force. Okay, so we have force due to gravity here pulling down, and we're saying at that moment we have the electrical force pulling up the same amount. That means, okay, those are balanced. So whatever the gravitational force would be, electrical force is same. What's the gravitational force? mg. Now this is positive physics, so the g is always 10 for what we're doing, because we're estimating anyway. 10 meters per second, or newtons per kilogram, since we did some gravitational field strength work. So I have a gravitational force of 0.837 newtons, which is also going to be equal, by definition of the problem, to my electric force. Great, so let's make sure I'm not crazy. 0.837. All right, not proof that I'm not crazy, but it's proof I got that right at least. Coulomb's constant, still 9 times 10 to the 9th, last I checked. And this is Newton meter squared per Coulomb squared to convert everything else. They give us the charges. Charge on the rod, 3.86 times 10 to the -7th. Bam. And this is measured in coulombs. And then charge on the pith ball, 3.37. Oh, now I'll show you what happens when I do this times 10 to the -7th. But Mr. J, it literally says that right there. But it also literally says, do not enter a negative in front of the charge. However they coded it, it gets cranky when you do. So absolute value, just give us the number, the amount, 3.37, and be careful of that. Sacrificed my accuracy score just for your knowledge. It's cool. It doesn't bother me. It totally bothers me, but I'll let it go. I can reset it. All right, the last thing we don't know is that distance, all right, that radial distance between the two. But we have everything else we would need to solve for it because, let's see, electric force equals K, Q1, Q2 over D squared. I could plug in all this stuff here, right, and then solve for D squared. I kind of like to rearrange algebraically first. That's just my jam. Multiply D squared by both sides, so it cancels out here. I get D squared times the force equals K, Q1, Q2. I want D by itself because I want a D equals. So I'm going to divide by the electric force, and I get D squared equals K, Q1, Q2 over the force. Last but not least, I take the square root of the whole thing to get the distance, and I would take the positive square root when I actually finally calculate that. And there we go. Now I can plug in some values.